Hi everyone, welcome back to Mr. Edmond's channel. Today we go through P4 October 2025. Don't forget to subscribe if you haven't done so. Thank you. Let us go through the paper. Question one, we have a binomial expansion. Find the first four terms of this expansion here. Is going to use a binomial. Remember, your binomial is 1 plus x at the power of n is equal to 1 plus nx plus n into n minus 1 over 2 x squared plus n into n minus 1 n minus 2 over 6. That's 3 factorial x power of 3. Now, when you see this expression or the binomial formula, it is 1 plus x, but what we have here in our equation, you have 2 plus 5x. So what we need to do first, we need to factorize the two outsides, such that the equation or the expression looks exactly like this. All right, so what we do here, I will just have a big bracket here, then I put 2 outside. So I have 1 plus, when you factorize 2 outside, that means you're going to divide by 2. Here, 5 over 2, all of it power of negative what? Negative 2. So my expression will be 2 power negative 2, which is going to be 1 over 4 into 1 plus 5 over 2x, the power of negative 1 over 2. Now we can apply our expansion, our formula. So we have 1 over 4, the binomial. Now this is our new x. This is our new x. This is our new x for this equation here. So it's going to have 1 plus nx. Our n is negative 2, and then your x is 5 over 2x. That's the first one. The second one is n, which is negative 2 minus 1, which is going to be negative 3, all of it over 2. This multiplied by your x squared, but your x is 5 over 2 x squared, plus the next term here, because one the first 4 terms, so I have 1, 2, 3, 4, one more, plus n minus 1 and n minus 2 over 6, but all of this over 6, but all of this you're going to multiply it by our x, which is 5 over 2 x cubed. All right, so that means we have our final answer here. So before I open the bracket, I'll try to simplify the inside. So I have 1 minus 5x. So you have here 5 minus 5x, and then this one here is going to simplify to 75 over 4 x squared, and then the next one would be minus, when you simplify this inside here, the power of 3, you have 125 over 2. You can do this step just to keep it safe, but you can as well skip it. So your final answer is going to be 1 over 4. 1 over 4 minus 5 over 4x, and then here plus 75 over 16x squared minus 125 over 8x cubed. That's going to be your expansion. The next part of the equation, part B says that one state the range of the value, the range of x for which the expression is valid. Remember, this expansion over here for the binomial is valid when x is less than 1, or when x is between -1 and 1. So what we have here, our new x that we're using in our expansion, the x we used is this one over here. That was our x in expansion. That means the answer for this, we are saying that 5 over 2x is less than 1. So when you make x the subject, so you have your x as the modulus of x less than 2 over 5. That's your answer for part C. Or you can think about as 5 over 2x is between -1 and 1, multiply by 2, and then divide by 5. So multiply by 2, -2, and then this is 2, divide by 5. So your x is between -2 over 5 and 2 over 5. Part C of the equation. You can see parts of the equation. They're asking you to find this expression here. So part C, you have 4 over 2 plus 5x, all of it to the power of 2. Now this means that you have 4 to the power of 2 multiplied by 2 plus 5x. I brought it up, is going to be negative 2, because when you have this up, it's going to be a negative. So that means, but this is exactly what you have just got in part B, in part A. So that means your answer part C is going to be just 16 multiplied by your answer in part A, which is 1 over 4 minus 5 over 4x plus 75 over 16x squared minus 125 over 8x cubed. And then your final answer here, so what you have is 4 minus 20x plus 75x squared. You can see that this is your answer. We don't need this one here. We don't need this, because in the question they said only up to x squared. So for question 2, we have a diagram here. This diagram here shows the sketch of a curve C, and the curve C is given by this equation, and the region R is bounded by the curve C. The line x is equal to 2 and the line x is equal to 8. Now, this region R is rotated through the 2 pi radians about the x-axis to form a solid. Now, what the question is asking us is to find the exact volume of this solid that has been formed. Now, this solid is called the solid of revolution, and you know the formula for the solid of revolution is pi, the integral from A up to B, the small unit up to the upper unit of y squared dx. That means our volume for this region R rotated, the solid form is going to be the integral from 2 up to 8 of y squared dx. All right, that means we can do it over here. So our volume is equal to pi into the integral from 2 up to 8 of our y squared. Y is 5 over 3 square root of x minus 1, all of this squared. Now, so when we simplify this, we have pi, the integral from 2 up to 8 of 25 over 9 into x minus 1. So the square root disappears. All right, so then you have, now we can integrate. I always want to put my constants outside, so this 25, so I put 25 pi over 9 outside, and I have the integral from 2 up to 8 of x minus 1 dx. So when you integrate here, you have your 25 pi over 9 outside, then integrate what you have x squared over 2 minus x, and then you have your limits from 2 up to 8. I'll keep my constant outside for simplicity, and then I have inside substituting 8, so I have 8 squared, which is 64 divided by 2, which is 32, minus x, which is minus 8, minus, when substituting 2, you have 2 squared over 2, which is 4 over 2, which is equal to b, which will be 2, minus 2. All right, you can see, so this is going to be 0, and then this is just 24. So your answer is 25 over 9 pi multiplied by 24, which is 200 over 3 pi. These are your units cubed. So that's your answer for question 2. Question 3, so I've got question 3. Question 3, we have a parametric equation, so x equals that, and then y is equal to that. The first question you want, they're asking us to do is to find y as a function of x. So we are changing into the Cartesian equation. So the easy thing to do here is to make t the subject from the x, so x is equal to t plus 15 over t plus 4. So to make t the subject, I'll multiply t plus 4 on the other side. So you have xt plus 4x equals to t plus 15. Collect terms. So you have this as xt minus t is equal to 15 minus 4 for x. Now, here you factorize the t outside, so you have x minus 1, and this is equal to 15 minus 4x. So you see that your t is equal to 15 minus 4x, all of it over x minus 1. Now you're going to substitute this t you have made a subject into the y, so that you can get your answer. So you have your y as equal to 5 over t plus 2. Let us substitute. So what we have, it means that our y is 5, all of it over t. But what's our t? Our t is 15 minus 4x over x minus 1 plus 2. That means we have our y, this one is equal to 5 over, we try to add a fraction here, so this is going to be 15 minus 4x. I'll just put a bracket just for us to see what you're trying to do over here, over x minus 1 plus 2 into x minus 1. All of it is now over what? Over x minus 1. You can have less steps, but I'm just writing all the steps for you guys to see. This is x over, the denominator ends up to be x minus 1, all of it over 15 minus 2, which is going to be 13. And then you have minus 4 plus 2, which is equal to minus 2x. So you're dividing, so you keep change flip, so you end up with your answer as 5 into x minus 1, all of it over 13 minus 2x. That's your first part, which you can as well write as, you can write this as, say, 5x minus 5 over 13 minus 2x. Now the next part is you have to have a domain of this graph, and also you have to get the range of the graph. All right, still on part A, we need to find the domain of this function here, and then part B, we need to find the range of that function. Now if you want to find the domain of that function, which is e to f, we need the range of the x values. We need the range of x, where the x is a function of what? Of t. And in order to find part B, to find the range of, or the range of what? To find part B, find the range of y as a function of x, we need the range of what? The range of y as a function of what? Of t. That means this e to f, we are going to find the range of t plus 15 over t plus 4. Now, there's a shortcut here. If you checked one of my first videos on P4, I have a detailed explanation, but you have a shortcut here. Now, the shortcut for this is what I'm going to do. They say that t is greater than what? T is greater than 1. I'm going to substitute in t as equal to 0. T as equal to, when I put in t as equal to 0, I'm going to end up with x as equal to 15 over what? Over 4. Then the other value that I'm going to look for, the other value is going to be, when I sketch this graph here, this reciprocal graph, I'll always have what you call the horizontal asymptote. How do you always get the horizontal asymptote? The horizontal asymptote is going to be got by dividing the coefficient of the t over here. And the coefficient of t is going to be 1 divided by 1. That means that horizontal asymptote is 1. That means your x value is between 1 and 15 over 4. So that means my x value here is between 1, the smallest one. If I'm not visualizing the graph, I just have to see the smallest one and the smallest one, the biggest one. So 1 being the smallest one and 15 over 4 being the largest. And this one is equal to, because you got it at t is equal to 0, but this one is an asymptote, so it's going to be like that. Now for this, for the y, we have the y function. So the y is 5 over t plus 1, 5 over t plus 2. Still substituting t is equal to 0. When you put in t is equal to 0, you have 5 over 2, right? That's a 2.5. Now we think about the horizontal asymptote of this graph. The horizontal asymptote of this graph. All right, because this one I told you is just t over t, I mean the coefficients of t over here. But when you think about it, the coefficient of t over here is going to be 0. So that means the horizontal asymptote is going to be y as equal to 0 over what? 0 over 1, which is y as equal to what? As equal to 0. Or you can see it as a shift of the graph 1 over what? 1 over t. That means you have two values. You have the 0, y is equal to 0, and then you have y is equal to 5 over what? 5 over 2. That means your y value is between 0 and 5 over what? 5 over 2. But the 5 over 2, the 5 over 2, you got it when you substitute in what? When you substitute in t is equal to 0. That means this is equal to 0. But this one is not possible because it's just the asymptote. That's how you get your domain and your range. So this is the answer for B, and this is the E. The E x between E and what? E and F, like that. Question 4. Question 4. Implicit differentiation. So we have the curve given by this equation. Alright, equation again here. This is for x squared plus y squared minus 2xy equals to 24x. We want to find dy dx in terms of x and y. Alright, so that means what you have here when you do implicit differentiation. So here you have the derivative as 8x plus the derivative here as 2y dy dx, and over here I always want to factorize the negative outside. Look at this as a product rule. So this is 2y, so you're looking at it as this is your u, and then this is your u of v. Remember the product rule, the derivative of u multiplied by v plus the derivative of v multiplied by what? By u. So the derivative of u, which is 2x, is just 2, multiplied by v, which is y, plus the derivative of y, which is 1, y dx. The derivative of this is just 1 dy dx multiplied by the u, which is a constant now, which is 2 what? 2x. This one equal the derivative on which of 24x, which is 24. That means you collect like terms. So I have 2y dy dx. And then we have, when you open the bracket for the dy dx, you see that you're going to have minus 2x dy dx, and then move everything on the other side. So you have 24, and then you have the 8x, which is minus 8x, and then you have, when you open the bracket here, you have minus 2y. It goes, it becomes what? Comes a plus 2y. Factorize the y outside, dy dx. So what you have? You have 2y minus 2x as equal to 24 minus 8x divided plus 2y. That means your dy dx is going to be, I'm going to divide everything by 2, so I have 12 minus 4x plus y, all of it over y minus x. That's your dy dx. Part B of the equation, we go back here. So part B of the equation, they've given us a condition here. So the point is a point P that lies on the curve C. The gradient of C at P is 2. That means the dy dx, because the dy dx is a gradient, the dy dx is equal to what? Is equal to 2 at point what? At point P. And the coordinates of P, we have A, B. These are the code, this is the x and y value. So find the values of A and the value of B. Let us see what we are doing over here. Now, since the dy dx is equal to 2, so what we are saying here for this part B, what we are saying that the dy dx is equal to what? Is equal to 2. That means your 12 minus 4x plus y over y minus x is equal to 2. Now, you can cross multiply here, so you have 12 minus 4x plus y equals to 2y minus 2x. Collect like terms, so I'm going to put the y here. So here I have 2 minus 2y, so I have y there. The 2 goes to the other side, so I have 12 minus 2x. Now, what you're going to do, you're going to get this equation. I call it equation 2. And we are going to substitute it in our first equation, over here, because this is the equation for x and y. So you have two simultaneous equations. So I will write this over here. So this is the first equation, or the equation of the curve, which is 4 x squared plus y squared minus 2xy equals to 24x. So this is your first equation. So this is the condition for the point where dy dx equal to 2. So I want to substitute insert here, solve them simultaneously. So we have 4x squared plus 12 minus 2x squared minus 2x into 12 minus 2x, all of it as 24x. Now what we have, we can expand the brackets here. Now when you expand the bracket, you do the math quickly here. Be careful with the negatives here. So we have 144 minus 12 times 2, which is 24 times 2, which is 48x, and then here plus 4x squared. This one here minus, when you open the bracket, you have minus, so you have 2x and 12 minus 24x, and then you have here plus 4x squared. This one equals what? Equals to 24. All right, so we try to cancel things out here. So you're going to end up with 12. This is 4 and 4 and 4, so you end up with 12x squared. This is 48 minus 24, and then 4 comes on this side, minus 96x, and this is 100 and what? 144. So your quadratic equation, when you try to simplify here, your quadratic equation is going to be divided by 12x squared, and this is going to be 8x plus what? Plus 12 equal to 0. You do the solving, and then you end up with your x as equal to 2, and your x as equal to what? As equal to 6. Now, you need to get the y value. But now, the key thing of what you have to be careful here to get the y value, you have two equations. You have this equation here, the condition, and also that equation, the equation of the graph. Now, when you're substituting, you substitute in this graph, in this condition. Now, we substitute back, so you're saying that in that condition, our y is going to be 12 minus 2x. Now, remember, I don't know which point I'm looking for, but you have one point. But we shall see that from the y values. So at x is equal to 2, when you substitute in x is equal to 2, you end up with your y as 8. And when you substitute in x as 6, you end up with your y as 0. But remember, the condition was that a is greater than what? A is greater than 0, and also b is greater than 0. And that point of a greater than 0 and b greater than 0 is this one over here, because for this is 0. So your a is equal to 2 and your b is equal to 8. That's the next part. That's part B. Thank you. All right, question 5. So question 5, we have a line L1 given by this equation and line L2 given by that equation. Then they have told us that L1 and L2 intersect at point P. Now we need to find the value of beta. Beta, this one over here, we need to find the value of beta. Now, the condition here is that if these two lines intersect at one point, the x in line L1 is the same as the x in line L2. The y in L1 is the same. That means they intersect at some point. That means the x over here in line L1, which is 2, remember, this R stands for x. The R stands for xy, xyz. Now, it means that x in L1, line 1, is 2 plus lambda, and the y, so that's the x, and the y is minus 1 plus 4 lambda, and the z is 3 plus 2 lambda. It is something for this one here. The x is that, the y is that, and then the z is that. So if they intersect, it means that L1 equals L2. This is just for explanation. That means that 2 plus lambda is equal to minus 1 plus 2 mu. That's the first one. And then you have for the y values, minus 1 plus 4 lambda is equal to beta minus mu. And then you have the last one, 3 plus 2 lambda is equal to 6 plus 7 mu. This is equation 2, and this is equation what? Equation 3. Now, what I'm going to do, I'm going to focus on equation 1. So equation 1, I move everything on one side. The unknowns, I have lambda minus 2 mu is equal to minus 3. That's equation 1. Now, equation 2, I'll skip equation 2 because as beta, so I use equation what? Equation 3 for the z. That means I have 2 lambda minus 7 mu is equal to 6 minus 3, which is equal to 3. So what you're going to do, you're going to solve these equations simultaneously. And if you solve this equation simultaneously, you're going to find out that your mu is equal to minus 3 and your lambda is equal to minus 9. You can solve this in the calculator. That means at the point of intersection, the condition is that lambda is equal to minus 9 and mu is equal to minus 3. So how do you find beta? That means this lambda over here should also satisfy the second equation. And the second equation says that minus 1 plus 4 lambda is equal to beta minus mu. We have the value of lambda, so minus 1 plus 4 into lambda, which is minus 9, equals to beta into beta minus mu, whereby mu is minus 3. You place your calculator and then you find out that your beta, so your beta is equal to minus what? Minus 40. That's part A of the question. Now part B of the equation, they're asking us to find the point now, the point of intersection, but you have already found the condition. The condition says that for the point of intersection, lambda here is equal to negative what? Is equal to negative 9, and mu is equal to negative what? Negative 3. So all I do, I just have to substitute in back. So I can use n of the equation. So I'll use this one here. So x, y, z, the point of intersection, is equal to 2 minus 1, 3 into, use your lambda. Your lambda is minus 9. Minus 9 into 1, 4, and what? And 2. So that means your x is 2 plus minus 9. That means you have your x as minus 7, and then the next one you have minus 1 plus minus 1 plus minus 36, so minus 37, and then you have 3 plus minus 18, which is equal to minus 15. That's your point. That's your point P. Thank you. All right, question 6, substitution. I don't expect anyone to get this question wrong. Always follow through the steps if they give you a substitution and get the correct answer. So we have u as equal to 3 plus cos of theta. So what you're going to find first is the u, the theta, which is equal to minus sine of theta. And then the other thing you're going to do, you're going to look at the limits, 0 to pi. So change your limits here as well. So for your limits, you have the limits of theta, and now we have the limits of u. Theta is equal to 0, but remember u equals what? That means my u is going to be equal to 3 plus cos of theta. Cos of 0 is equal to 1. So cos of 0 is equal to 1. That means this is going to be 4. And for pi by what? For pi by 2, we know, so u is equal to 3, so we know that it's going to be 3 plus cos of pi by 2. Cos of pi by 2 is pi by 2 is 90, cos of 90 is 0, so this is going to be 3. These are your new limits. All right, now let us go back into the integration. Let us do the substitution. I will not focus on the limits for now. I just focus on the integral. So sine of 2 theta over the square root of 3 plus cos of theta, the theta. Substituting, don't do anything, just substituting, only that. So that means I have this as the integral of sine of 2 theta over, this is our u, let's say that's our u, square root of u, multiplied by the theta. The theta is when you make the theta subject here, you're going to end up with this one going on the other side. So you end up with the u over negative sine of theta. That's going to be your integral. Now, what we need to do now, you can see that nothing is cancelling out. That means you have to think about how to remove this one over here, and you can move this using the trig identity of the double angle. That's sine of 2 theta equals to 2 sine theta cos of theta. That means your integral now is going to be this is 2 sine of theta cos of theta over u to the power of a half multiplied by du over negative sine of what? Of theta. You can see this one's going to cancel out. And then you are left with the cos. That means you have your integral as negative 2 into the integral of cos of theta over u to the power of a half du. Remember, always want to put the constant outside as long as it's a multiplication. Now, you remember that your u is equal to 3 plus cos of what? Plus cos of theta. So make theta is equal to u minus what? U minus 3. That means your integral now is minus 2 into the integral of u minus 3, all of this over u of a half du. I simplify your equation, so you have minus u to the integral of u to the power of negative. It's going to be 1, which is not negative, it's positive, which is a half, minus 3 u to the power of negative what? Negative a half du. Now I can bring back my limits. Remember, the limits were from 4 to what? 4 to 3. Now integrate. And so when you integrate and then put in the limits, so your integral, I will just write over here, your integral here, minus 2 is outside. I get my integral here as you add, which is going to be 3 over what? 3 over 2, and then you divide by 3 over 2, it should be just 2 over what? 2 over 3. Minus, you add, which is going to be a half. You add 1, which is a half, and then a half here, divide by a half, which is going to be just 2. Close the brackets, and then you have from 4 to what? From 4 to 3. Now, for simplicity, what I'll do, I will just open the brackets. There's a mistake here. This, I forgot this none over here. So this is 3. So it should be a 3 over here. So that means it's supposed to be 6. All right. To make it simpler, I will open the bracket. I'll bring my 2 inside. So the limits I'm going to apply the limits. So this is going to be, this will be plus 12. So that means I'm going to have 12 u to the power of 1 over 2 minus 4 over 3 to the power of u to the power of 3 over what? 3 over 2. Now, substituting your limits is about how you're going to simplify this. Now, when I substitute in 3, what I have here, I have 12 into root of 3. Minus 4 over 3. If you have 3, remember you need the exact answer, exact value. If you have 3 to the power of 3 over 2, this is the same as having 3, that's 1 power, and then times 3 to the power of what? I have the 3 over 2. That means this answer here is 4 over 3 times 3 root what? Root 3. Then minus 12 times root of 4, which is 2. Minus 4 over 3 multiplied by 4 to the power of 3 over 2. You can do it quickly. So this is the same as having 3 to the power of 1 and then 4 to the power of 1 and then 4 to the power of what? A half, which is 4 times what? Times 2, which is 8. So this one is 8. Then you can simplify this. You You see that you're going to end up with this one here is going to be this minus 4. So this will be 8 root 3. And then when you press a calculator for this one here, you're going to end up with 40 or what? 40 over 3 as your final answer. Question 7. You have vector here. So you have a parallelogram. A, B, C, D, and you have vectors A and vectors B, C, and you have the angle theta, which is between 0 and 90. So the first question, they're asking us to find the exact value of cos of what? Of cos of theta. Now, remember from the product rule, remember that A dot what? A dot B is equal to the modulus of A times the modulus of B times cos of what? Of theta, where theta is the angle between A and B. That means the cos of theta, we know that is equal to A dot B over the modulus of A and the modulus of what? The modulus of B. So that means what you're going to do here, we're going to find the modulus of AB, which is the square root of 6 squared plus 2 squared plus 3 squared. You can see I'm not bothered by the negatives. So this is 38 plus 4 plus 9, which is equal to 49, which is equal to 7. And then we have the modulus of BC. The modulus of BC, square root of 4 squared plus 3 squared plus 5 squared. This is 25 and this is 25, so that is 50. So to 50, which is equal to 5 root 2. And then we have to get AB dot BC. AB dot BC. So you have 6I minus 2J plus 3K. We are dotting this with minus 4I plus 3J plus 5K. No, this is a minus 5K. So our answer here, you have 6 times minus 4, so you have minus 24, and then minus 2 times 3, so you have minus 6, and then you have 3 times minus 15, so you have times 5, so you have minus 15. That means our A dot B is minus 45. All right, so now we put in our formula. So we have cos of theta, the cos of the angle, as equal to the modulus. Remember, using the formula over here, using this formula that we just started with, the formula over here, the modulus, the dot product over the product of the modulus. Okay, and then we just substitute in here. So you have the dot product, which is minus 45, over the modulus is 7 times 5 root what? Times 5 root 2. And your answer here is going to be, you are going to simplify and rationalize. You can just put in your calculator, and your answer is going to be negative 2 root 2 over 14. But there's one thing you should remember, that the angle they're talking about over here is an acute angle. That's the angle between 0 and 90. The cos is always positive. That means what you have got, the dot product has given us the obtuse angle, which is the angle that is over way this side. That means for the acute angle, they're going to have the same cos. They're going to have the same cos, but positive. That means this is cos of theta as equal to 9 root 2 over 14. That's your answer for part A. Part B of the equation, they're asking us to show that the area of a parallelogram is given by that. Now, if you're going to find the area of a parallelogram, what we'll do, we'll just look at the diagram here as two triangles. So we try to find the area, and these are two congruent triangles. So the triangles are equal. So we'll find the area of one triangle and multiply by 2. And we have already found out that the modulus or the size of AB is 7. So the size of AB is 7. So this side is 7, and then this side is 5 root of what? 5 root of 2. In order to find the area of a triangle, you remember that the area of a triangle is a half AB sine what? Sine C. But the problem is we don't have, so this is the A and then the B, but the problem is we don't have the sine of what? The sine of the angle C, or the angle of theta we are talking about here. Now, but what we know the cos. We know the cos of theta as equal to 9 root 2 over 14. So what you're going to do, we are going to remember our trig identity, that the sine squared of theta will be equal to 1 minus the cos squared of theta. That means our sine of theta is the square root of 1 minus the cos squared theta, which is 9 root 2 over 14. This is square root. Then you press that on your calculator. You find out that your sine of theta is equal to root of 34 over 14. Don't press sine cos inverse together to get the angle, because when you press the sine, you may not get an exact answer. So that's the sine. That means our area of the parallelogram is a half A, which is 7, and B, which is 5 root of 2, multiplied by the sine of the angle, which is root of 34 over 14. But this will give the area of one triangle, and then you multiply this by what? You multiply that by 2. Now when you do that, you get your final answer. You can put in your calculator, or you can do some quick math here, and then you end up with your answer as 5 root 70 as your area of the parallelogram. All right, question 8. So question 8 says that a container initially has 6 liters of water. Then water starts to flow into the container. The rate at which water flows the container is modeled by a differential equation. This one over here, dv, we have dv dt as equal to 12t e to the power minus t. And then what the question is asking us to do over here is to solve this differential equation and use the initial condition to find the equation of for v in terms of what? In terms of t. The initial condition is this, that initially the container has 6 liters of water. All right, now let us see what you're going to do here. In order for us to solve the equation, we're going to separate variables. Now, all the equations, differential equation in P4, they're all first order separable equations. So I have dv is equal to 12t e to the power of negative t dt. So I'm going to integrate this and then integrate that side. Now, when you integrate this side, you're going to end up with v is equal to the integral of 12t times e to the power negative t dt. Now, this integration is integration by parts. So you're going to see you have this one over here, this part. All right, and then you also have that part. So integration by parts. And remember the integration by parts, the integral of u and derivative of v is equal to uv minus the integral of derivative of u multiplied by v. But this integral over here is a good one because we have e. That means we can use the di method. So I'll use the di method for this integral by parts. So this is the di method. The di method means that one of the function you're going to keep on differentiating it. That means it's going to be the 2e. You're going to keep on getting the derivative. And the other function, you're going to keep on getting the what? Getting the integral. Now, this is the shortcut of the by parts. This is the di method, the shortcut of the by parts. So what you're going to do over here, so the d, you're going to keep on differentiating it, and the I, you're going to keep on integrating it. So our d is the 12 of u. In this case, d is like the u, and this is the v what? The v prime. So the u, you keep on differentiating it, and the v prime, you keep on integrating it. So when you have the derivative of this 12t, you're going to end up with 12, and the integral of this will be negative e to the power of negative t. Go on. The derivative of this is 0, and then the derivative of this is going to be the negative comes down here. The integral will be e to the power negative what? Negative t. Now your di method, what it says, your answer is going to be the 12t multiplied by that, and then the 12 multiplied by this. But the answer for this is going to be negative. This one is going to be positive. So your integral now, now we can join it together. The integral, this integral here, is going to be 12t times negative e. So this is 12t into e to the power of negative t, plus, but this is going to be minus 12 multiplied by this, which is e to the power of negative t plus what? Plus c. This is your integration. Now here using the di method, it makes the integration by part very simple. But you need to find the value of c. The value of c, say we know that at t is equal to 0, initially at t is equal to 0, v is equal to 6. That's what they said in the question. That means when you replace 6 here, and then you have 0, all of this. This will be 0, e, this will be 0, it doesn't matter, minus 12, e to the power what? E to the power of 0. You see that, so this is t, this is 0 over here on top. You see that, then plus c. You see that you have 6 is equal to minus 12 plus what? Plus c. So your c is equal to 18. That means your volume v is equal to minus 12t e to the power minus t minus 12 e to the power minus t plus 18. That's your answer for part A. So that's your formula for the volume. That's what they want you to find for part what? For part A. Now, Part B says that given the capacity of the container is 20, determine according to the model whether or not the container will ever become full. Give a reason for that. Now let us go back to the answer we have. Now, this V here, at any point, at any time t, the volume is minus 12t e to the power minus t minus 12e to the power negative that plus what? Plus 18. Now, if you have any time t, you just substitute in the formula and then come up with the answer, come up with the volume. But you have to note one thing here. You see these functions over here? This function here, they have a variable which is negative 2e, negative e to the power of e to the power. It has a function which is e to the power of negative t. Now this function here, as t goes to infinity, that function over here, e to the power negative t, goes to 0. So as soon as goes to 0, if you think about the graph of that function, looks like that. That's the graph of the function. So as this x goes to infinity, as it goes bigger, the y value will go to what? Will go to 0. It's going to what? It's going to 0. So this one goes to 0. That means our v, this function over here, all of it goes to 0. Then as t goes to 0, that means v is going to be equal to 18 as t goes to what? As t goes to infinity. That means the maximum volume of this, the maximum volume is going to be 18. The maximum volume is 18. That means the container can never be full because the container has a volume of 20. But according to our model, the maximum volume is what? Is 18. All right, question 9. We have question 9. We have a graph. So we have a graph here, and then you have the equation is given parametrically. So you have x, and then you have y. Let us see the first question. The first condition here says that at a point P lies on the graph, given that the gradient of C at P is 4. Now, when they say the gradient, we know what you're talking about over here is a dy dx. That means the dy dx at that point is negative what? Is negative 4. So what we need to figure out, the value of the exact coordinate, the exact y coordinates of what? Of P. We're going to use the chain rule here. First, we need to find the derivative of x. So the x dt, remember the derivative of the natural log function. You get the derivative of the function inside, which is going to be 2 in this case, over the function itself, which is 2t plus 5. That's the x dt. Now for this one, the y, I'm going to put it up, and I have it as t plus 1 to the power negative 1. And then I'll use the chain rule. The negative 1 comes down. The derivative of the inside, but which is 1, so it doesn't change. And then negative 1 minus that, which is 2. And you can write this. You can take the 2 down and write this as negative 1 over t plus 1 squared. Now, I want to find y dx. I prefer using the chain rule. I prefer this method. So y dx equals to y dt multiplied by dt dx. I prefer using that other than the division. That means my dy dx here is dy dt. What's y dt? Which is 1 over t plus 1 squared, but negative, multiplied by dt dx. Dt dx, I'm just going to flip this. Dt dx, which is 2t plus 5 over 2. That's your dy dx. All right, so but in the question, they have just told us that dy, the x or the gradient is negative what? Negative 4. So what you're going to do, you're going to have our dy dx, which is negative of 2t plus 5, all of it, over 2 into, this is t, not 2t, into t, this is t plus 1 squared. All of this is equal to negative 4. Now cross multiply, you can have this negatives cancel out. That means you have 2t plus 5 is equal to 8 into t plus 1 squared. I'll have this as 2t plus 5 equals to 8t squared, and then inside here you're going to have 16t, then plus 8. When you collect like terms, your final equation will be 8t squared plus 14t, and then plus 3 equals what? Equals to 0. Then when you solve your quadratic, you can use several methods of the quadratic. You have your t as equal to negative 3 over 2, and the other value of t as equal to negative 1 over 4. But in the question, let us see, in the question, they said here that t should be greater than what? Therefore, we are going to take this one over here. T as equal to negative 1 over 4. That means our y value is going to be 1 over, what's the function, the equation for y? 1 over t plus 1. 1 over t plus 1. That means our y value is 1 over negative 1 over 4 plus 1, which is 1 over 3 over 4, which is 4 over 3. That's your y value. Therefore, for part A, your y value is 4 over 3. Part B of the question. Now they say that there's a region R. The region R is shown in the figure. Of this region R over here. This region R is bounded by the curve and the line natural log of 9 and natural log of 15. So what the first question is asking us to do is to show that this area is given by that integral where a, b, and k are constant to be found. Now we go back here. I'm going to use this space. So if you want to find the area here, we know that the area under the graph is always the integral of y with respect to x from the lower bound to the upper bound. So in this case, our area will be the integral from the lower bound, which is natural log of 9, to the upper bound, which is natural log of 15 of y dx. But when you replace your y, you see that our y here is in terms of t. That means we have 1 over t plus 1 multiplied by the x. But we don't have the x, but from part A, we have already seen that when x is equal to natural log of 2t plus 5, we know that our dx dt is equal to 2 over 2t plus 5. That means we know that our dx is equal to 2 over 2t plus 5 dt. We have done this in part A of the question. That means our integral is going to be equal to the integral of 1 over t plus 1 multiplied by the x, and the x is 2 times what? 2 times dt over 2t plus 5. That means your area is equal to the integral of 2 over t plus 1 and 2t plus 5 dt. Now we need to figure out the limits as well, because the limits, these are limits for x. So if those are limits for x, we need to figure out the limits for the t. That means what you have here, we have the limit for the x. So when x is equal to natural log of what? Natural log of 9, and here also natural log of 15. But our x is equal to natural log of 2t plus what? Plus 5. Now that means you can see that in order to find this, you're going to say that 2t plus 5 is equal to 9. So you see that it is equal to 2. And you are saying that 2t plus 5 is equal to 15. Then you see that t is equal to what? T is equal to 5. So your limits are from 2 to 5. That is this part over here. That is a part B of the equation. It's the integral from 2 to 5 of 2 over t plus 1 into 2t plus 5 dt. Part 2 of B. Now part 2 of B, they're asking us to solve this equation. That's why they say that, hence using algebraic integration, find the exact value of R. Don't find the exact value of R, but remember, I have to give you your answer in this format. Remember that. Now, let us try to solve this integral. Now, for this integral, we are going to use partial fractions. We're going to use partial fractions here. All right, so I have this can be written in the form of a over t plus 1 plus b over 2t plus 5. Remember, you're just looking at the numerator. That means 2 is equivalent to a multiplied by 2t plus 5 plus b multiplied by t plus 1. For t equals to -1, I'm getting -1 from here because I'll make this one 0. So I have 2 as equal to, put -1 here, so I have -2 plus 5, which is equal to 3 what? 3a, and this one goes to 0, and this one goes to 0. Now what I have is that a is equal to 2 over what? 2 over 3. The next one, I want to make this one 0, so I'll put in my t as equal to negative 5 over what? 5 over 2. If it's negative 5 over 2, so I have 2 is equal to negative 5 over 2. This goes to 0. Plus b, if you put 5 over 2 over here, you're going to have which is minus 3 over 2, minus 3 over 2b. Now, what do you do over here? So I multiply by 2, so and then divide by 3. So you see that your b is going to be minus 4 over 3. All right. That means our integral now, is now going to be the integral of, now this changes to what? A is 2 over 3 over t plus 1. And then you have plus b, which the integral, this dt, which the integral of b, which is negative 4 over 3, 2t plus what? 2t plus 5 dt. That's now our integral. And the limits we have from 2 to what? 2 to 5. The limits are from 2 to 5. That's the area we're trying to find. Now, we go on to the integration. The partial fractions always create natural logs. So this is just a constant, over just a constant, natural log of t plus 1. Plus, even this one here, minus 4 over 3 is just a constant. But now for this one, there's a 2 here over here. The derivative of this 2 is 2. That means this comes out as 1 over 2, right over here, times 1 over 2, natural log of 2t plus 5. You should be able to do these integrals with ease. Right. Then here, from 2 up to what? From 2 up to 5. Before I substitute in, I'll do some kind of, just a simplification one step here. So this is 2 over 3. Natural log of t plus 1 and minus 2 over 3 natural log of 2t plus 5. And now we are putting in your limits from 2 up to what? 2 up to 5. Still, for simplicity, I'm going to put this one outside. I'll put this 2 over 3 outside as well. All right. And then when you're subtracting natural logs, what do? You divide. So this is natural log of t plus 1 over 2t plus 5. You don't have to do it like this, but I prefer doing it like this. Now here I have 2 over 3. Now you substitute in your values. So I have 5. So that means I have natural log of 5 here. I have 6. 6 over, put in 5. This is 10. 6 over 15. Minus natural 2. When you substitute in 2, you have 3 on top, and then down here you have 9. This is 1 over 3. This will be 1 over 3, like that. Now when you simplify it, so you have your 2 over 3 natural log of, when you're subtracting, what do? You divide. So this is this over 15 multiplied by 3 over 1. So your answer here is 2 over 3 natural log of 6 over 5. Natural log of 6 over 5, but the answer as 1/3 of natural log of a. That means for the 1/3, what you need to see here, you need to see that this 1/3 is the same as having 1 over 3 times 2 natural log of 6 over 5. Then the 2 comes back inside, so your final answer will be 1 over 3 natural log of 36 over 25. That will be your final answer. Question 10, let us what I have in question 10. question 10 says that we have a statement x. The statement x says that if x squared is an odd square number, then x is an odd number. So a student was asked to prove this statement using proof by contradiction. So this is the working out the student did. So we have the negation. The negation says that assume that x squared is an odd square number and x is an even number. This is step one, the negation, the negative statement. Now, or the contradicting statement. Now, what we have here, the next statement is if x is an even number, then x can be written in that form, x is equal to 2m. So in order for us to complete the proof, all we need to prove, we need to get x what? X squared. So x squared will be 2m squared. That means our x squared is 4m squared, which is even. So x squared is even. So x squared is even, which contradicts the assumption. Which assumption are we talking about? Which contradicts the assumption, which is this one over here. Therefore, the first statement is correct. Therefore, the first statement is correct. So you have to write it and say, therefore, if x squared is an odd square number, then x is an odd number. That's part A. Part B of the question. We want to start with part B of the question. Say that use proof by contradiction to show that there are no integers a and b such that a squared minus 4b equals 27. So what you need to find here is the contradiction or the assumption or the negation. So you need the negation, or what you call it, your assumption you're going to make. The negation is the first thing you're going to make here. You're going to say that there are integers. So there exist integers a and b such that a squared minus 4b is equal to 27. A squared minus 4ab is equal to 7. Now, what we have here, look at this statement over here. This statement here, they say that you may assume this statement without further justification. That means we are going to assume this statement which says that if x squared is odd, then x is an odd number. So if we use that statement, what you're going to do, we are going to have our a squared minus 4b equals 27. That means we have a squared equals to 27 plus what? Plus 4b. Now the statement we have, statement x. So from statement x, we say that if these are integers, it means that a squared is what? A squared is odd. Then also a is what? A is odd. We assume that is true because they say we can assume that this statement is true. All right, so let us see if a squared is odd and a is odd. That means what you're going to say, we are going to say that if a is odd, that means a is equal to 2, say 2n plus 1. Therefore, we have our a squared as equal to 27 plus 4b. All right, we move on. And then we say we square this, so that means we have 2n plus 1 squared is equal to 27 plus 4b. When you square here, you have 4n squared plus 4n plus n equals 27 plus 4b. We want to find the value of b because it said a is a positive integer. So we want to find the value of b. What would the value of b going to be if a is a positive integer? So you see here you have 4n squared plus 4n, and this is going to be minus what? Minus 26 equals to 4b. That means b is going to be equal to n squared. I'm dividing both sides by 4. N squared plus n minus 26 over what? Over 4. Now when you see here, this over here is not an integer. Therefore, b is not an integer. But what was your assumption? Your assumption was that there exist two there exist integers a and what? A and b. But what you have proved here is that if a is an integer, which is an odd number, then the number you're going to come up with b is not going to be an integer. Therefore, the assumption, the negation or the assumption is wrong. The negation is wrong. That means that there exists, therefore there exists no integers. There exists no integers a and b for which a squared minus 4b equals to 27. That's your proof.